Hello friends, welcome to my networking video series. Today topic is you will study N plus network essential complete knowledge in this book. Let's start first chapter. In this chapter you will learn what is basic network and networking and identifying network components, type of network and network models. What is network topologies and logical topology. That's all.
Network basics. A computer network is formed when two or more computers, laptops, or mobile devices are connected. You can use the computers or devices that are part of a network to send and receive data and perform tasks, such as sharing resources. One of the biggest and most commonly used computer networks is the Internet. The Internet consists of millions of computers at different geographical locations across the world. Similarly, organizations also create private networks to send, receive, and share data. Using these networks, users can communicate with other users, conduct business, and shop and sell goods. These tasks were not feasible on standalone computers. The widespread use of computer networking has resulted in a requirement for highly qualified networking professionals who can plan, manage, and troubleshoot networks. This chapter focuses on the basics of networking and explains various network technologies and topologies. Objectives? In this chapter, you will learn to identify networks and their types. Identify various network models and topologies. Understanding the basics of networking. A network is a collection of computing devices such as computers, laptops, or mobile devices that communicate by exchanging data over a wired or wireless medium. In a networked environment, you can share data and applications and services with other users on the network. In addition, devices such as modems, printers, universal serial bus, USB drives, and CD-ROMs can also be shared among the users on a network. A common example of networking in organizations is where several employee computers share a printer or a scanner. To create a network, you require at least two computing devices. Network interface cards, NICs, in each connected device. A network medium, either wired or wireless. A network operating system, such as Windows, Linux, or Novell. The following figure displays a simple computer network. A computer network. Identifying network components. A network is formed by connecting computers and other special devices and components. The following list contains some of the commonly used network components. Node, server, client, peer, host. The following figure displays all these network components in a network. Network components. Node. A node is any device that can connect to a network to generate, transfer, and process data. Every node on a network has a unique address, which enables the other network devices to communicate with it. A node can be classified as an endpoint and a redistribution point. An endpoint functions as the start or end of data transfer. For example, a computer, a laptop, or a mobile phone acts as an endpoint in a network. On the other hand, a redistribution point acts as a device that transfers data. Examples of a redistribution point are a switch and a router. Switches work as a central device where all the computers and other devices are connected. It receives data from and transfers data to computers and other devices. Routers connect different networks and distribute the data of one network to another. Server. A server is a computer connected to a network. It performs the following functions. It shares resources with and responds to requests from computers and other servers. It provides centralized access to services such as email and resources, such as applications, files, and hardware devices, for example, printers and scanners. A server can perform either a specific function or multiple functions such as storage, email access, and internet access. Modern networks usually consist of multiple servers, which help to redistribute the workload in a network. Multiple servers also act as backup servers. If you use a single server and it fails, the server functionality will be lost. Client. A client is a system that uses services and resources provided by other computers and servers in a network. A client computer usually has its own processor, memory, and storage capacity, which enables it to perform its own tasks. For example, the computer used in an automatic teller machine, ATM, client dispenses cash and helps you to perform banking transactions. However, each client computer is connected to the bank's central server, which provides ATM's banking and customer information. Peer. A peer is a computer in a network that can act as both a client and a server. You use peers in small networks such as those in small shops and home networks to store, process, and share data. For example, in an internet cafe, all computers act as peers. These peers act as clients when they access the internet. The peers act as servers when you share data between computers. Host. A network host is a computer connected to a network. A host can function like a server or a storage device where you can store your files or data. A host is a device or a computer that is assigned an Internet Protocol, IP, address in a network. A host can access services from servers or provide services to the network. Hosts participate in the client-server model. A host can service multiple users and devices. A host can work like a data storage device, a print server, a file server, or a normal host machine for users to access data or surf the internet. You can connect different devices to a host to increase its capability for accessing more services. These devices include printers, scanners, cameras, and microphones. Understanding the types of networks. A computer network is classified into the following 4 types on the basis of its size. Local area network, LAN. Metropolitan area network, MAN. Controller area network, CAN. Wide area network, WAN. LAN. A LAN is a collection of computers and associated devices that share a common network medium. Typically, a LAN occupies a very small area, which can be within a home, an office building, or a school. LANs can be set up at a low cost. A LAN contains minimum 2 computers and is useful for sharing files and printers among users connected to a network. The following figure displays a LAN. A LAN. For example, a travel agency, XYZ Travels, has a small office where 4 employees process users' travel requests. All the 4 computers in the office access a common printer to print receipts and other office documents. The network formed by the 4 computers and the printer is a LAN. The LAN in XYZ Travels office makes it possible for all employees to use a common printer and share data and resources on the network. These are the main advantages of a LAN. In addition, users can store data centrally on the network's file server, which is the data storage location in the network. Users can also retrieve their data by using any workstation on the network. A LAN also has a few disadvantages. Setting up a LAN requires strong technical know-how. In addition, data and applications available over the network are vulnerable to unauthorized access. Therefore, special security measures, such as fingerprint scanners and access cards, need to be implemented. Additionally, if the file server fails or develops a serious fault, all the users connected to it are affected. Going back to the example of XYZ Travels, in the event of failure of a file server, the work of all the employees will be affected. However, such a situation cannot occur when users work on standalone computers. MAN. A MAN is a large computer network that extends to a campus such as that of a university or covers an entire city. Similar to a WAN, a MAN also incorporates a number of LANs to form the network, but its geographical spread is smaller than that of a WAN. CAN. A CAN is a network designed for the automotive industry. A CAN connects devices, sensors, and embedded devices by using a serial bus. Contrary to other popular networks, the devices in a CAN do not have addresses. Instead, nodes broadcast short messages by attaching identifiers unique to the network. A CAN is also popularly known as a campus area network. WAN. A WAN is a large computer network made up of smaller networks such as 2 or more LANs. The world's most famous and largest WAN is the Internet. WANs are costly to set up because of the expensive network equipment required. Computers in a WAN communicate with other computers using not only public communication networks such as telephone lines, but also leased lines and satellite communication. The smallest WAN can be formed by combining 2 LANs. The following figure displays how a WAN is formed by combining multiple LANs. A WAN. Apart from the Internet, other examples of WANs are networks used by multinational organizations such as retail stores that have outlets at many locations across several countries. For example, ABC Retail has a chain of large retail stores in several cities in the United States and Central Europe. ABC Retail is headquartered in Florida, United States. At each location where the company has offices, the computers are connected together to form a LAN. The LANs at various locations connect together and with the LAN at the Florida office to form a WAN. The WAN is used for business communication and other key business operations. ABC Retail benefits from the advantages that the WAN offers. Since the WAN covers a large geographical area, ABC Retail's offices at various locations across countries are able to connect to the same network, for data sharing and communication requirements. In addition, software and resources on a WAN are shared by connecting workstations. ABC Retail uses inventory management software that workstations in the various LANs can access using the WAN link. A WAN also has a few disadvantages, such as its high cost and slow speed of data transfer. In addition, a firewall needs to be set up as part of a WAN to restrict unauthorized users from disrupting the network. A WAN is expensive and complicated to set up and requires highly experienced technicians to maintain and manage. The bigger the network, the more expensive it is. 2 other forms of WAN networks are listed below. Intranet. Extranet. Intranet. An intranet is a private network formed by connecting multiple LANs. An intranet is used within an organization to share company information, training material, employee information, and other resources among the employees. For example, a software development company, Mobius Infosystems, created effort tracking software for recording the time spent by its employees on various tasks. The company made the software available on its intranet, for time logging by the employees. Since only those within the company have access to the intranet, the security of data and information shared with the employees is ensured. In addition, Mobius Infosystems can use the intranet to develop and deploy applications to support business operations and decisions across the enterprise. Another advantage of intranets is that they can serve as powerful tools for communication within an organization. Some examples of communication are chat, email, and blogs. A disadvantage of an intranet is the high cost of setting it up. Also, if an intranet is not properly organized, it can lead to chaos in the network and in the computers and systems connected to the network. Extranet. An extranet is a network that has controlled access to an organization's intranet. Therefore, an extranet can be considered an extension of the intranet of an organization. Usually, an organization's vendors, suppliers, and clients access its resources by using the extranet. For example, Mobius Infosystems works with a vendor Olive Quality Inc., which provides testing solutions. Mobius Infosystems shares its applications on an extranet, for testing by Olive Quality Inc. The extranet enables exchange of large amounts of data and collaboration among the employees of Mobius Infosystems and external individuals and other organizations. Another advantage of an extranet is that it provides a group of companies access to services provided by one company. For example, a company may manage the online banking system for various banks. A disadvantage of an extranet is that it is costly to develop and maintain. In addition, information shared over extranets should be properly controlled and checked to prevent its unauthorized access and misuse. Understanding the network model. A network model describes how the different devices in a network are connected and how these devices communicate with each other. As a network administrator, you can choose a network model according to your organization's requirements and from among the several standard network models available. The following list contains some of the standard network models. Point-to-point communication. Point-to-multipoint communication. Peer-to-peer. Client/server. Centralized. Point-to-point communication. In point-to-point communication, a direct connection exists between two computers. In this case, one computer can directly send data to another. Point-to-point communication can be implemented for both wired and wireless networks. The following figure displays point-to-point communication between two computers. Point-to-point communication. An example of point-to-point communication is a telephone call. In this case, one telephone is connected to another and only the caller and receiver communicate. Advantages of point-to-point communication are fast data flow and ease of maintenance and troubleshooting. Disadvantages of point-to-point communication include lack of security and redundancy. Point-to-multipoint communication. In point-to-multipoint communication, a single point in a network can interact with multiple points in the same network. Usually, telecommunications networks work on point-to-multipoint communication. The following figure displays a telecommunications system that works on point-to-multipoint communication. Point-to-multipoint communication. Point-to-multipoint communication provides ease of sending data and accessing resources simultaneously from different locations. This type of communication peer-to-peer. In a peer-to-peer network, all the computers in a network are responsible for communication and data sharing. Small LANs used in homes, schools, and small businesses are examples of peer-to-peer networks. All the computers included in a peer-to-peer network have the same associated applications and networking protocols. The following figure displays a peer-to-peer network. A peer-to-peer network. Consider an example. Arts University, a media training institute, has 5 computers in its media lab. Each of these computers is used for specific functions such as 3D modeling, 3D rendering, audio editing, video editing, and integration. In this scenario, All these computers in the lab can be connected over a peer-to-peer network. Client/server architecture. In client/server architecture, all computing resources and services are provided by a computer called a server. Other computers in the network that request resources and services from the server are known as clients. The following figure displays the working of a client/server network. Client/server architecture. For example, PQR Corp has an email server that provides all email services. There are many client computers connected to this server. Centralized network. In a centralized network, all network communication is controlled by a central computer. This central computer also performs data processing and storage for the other computers connected to it. The following figure displays a centralized network. Centralized network. An example of a centralized device is a host machine in the Internet. The host machine contains all the data related to a website. The data in the host machine is routed to the client through various computers and servers. An advantage of a centralized network is that the resources and data are easy to access using different devices and computers. In addition, it is easy to monitor the devices on the network. The main disadvantage of a centralized network is that if the central device fails, then the entire network fails. Also, since all the devices are connected to one client or device, the speed of the network is reduced significantly. Identifying network topologies. A network topology describes the physical structure and flow of data in a network. As the network administrator, you must understand different network topologies to be able to design networks. This is especially important when large network structures comprising computers, printers, modems, and servers need to be designed. Network topologies are categorized into the following two types. Physical topology. Logical topology. Understanding the physical topology. A physical topology describes the physical wiring, cabling, and shape of a network. As a network administrator, you must be aware of the physical topology of a network to be able to successfully execute network management tasks, including fault monitoring and network troubleshooting. The following list contains some of the common physical topologies. Bus topology. Star topology. Ring topology. Mesh topology. Tree topology. Hybrid topology. Bus topology. In a bus topology, all the nodes are connected to the main cable in a linear way. A T-connector connects the main cable to each node. The main cable is known as the bus, and it acts as the main communication channel. A bus also allows bidirectional data transmission. Both ends of the bus need to be properly terminated using star topology. A star topology uses a central connectivity device, such as a switch, that connects all the individual nodes in a network. Each node in a star topology communicates to other nodes in a network through the switch. The star topology is easy to maintain and reliable. The main disadvantage of a star topology is that if the switch fails, the entire network fails. The following figure displays the basic structure of a star topology. A star topology. Consider an example. In a network, you can use a hub or a switch to connect a scanner or a printer. Next, you connect all nodes to the hub. As a result, all nodes can access the scanner or printer, and this forms a star topology. Ring topology. In a ring topology, each node in a network is connected to two adjacent nodes and therefore forms a circle. The two adjacent nodes are known as the upstream and downstream neighbors. The flow of data in a ring topology is unidirectional. Data collision is prevented in a ring topology by using media access methods such as token passing. The absence of a central connectivity device enables each node in the network to handle all the signals in the network. Each node analyzes the signals received, accepts the signals meant for it, and forwards the remaining signals. The following figure displays the structure of a basic ring topology. A ring topology. The ring topology is used in engineering and manufacturing industries. The nodes that manage or monitor each process in an engineering or manufacturing industry are connected in a ring topology. Mesh topology. In a mesh topology, each node in the network is directly connected to every other node in the network, allowing simultaneous communication among the nodes. Since each node has dedicated lines connecting it with every other node in the network, data transfer and communication is very fast and reliable in this network topology. The following figure displays the basic structure of a mesh topology. A mesh topology. An example of a mesh topology is a mobile communication network. Communication on mobile networks is reliable because even if one mobile tower fails, the other mobile towers provide continued service. Tree topology. A tree topology follows a hierarchical structure where a root node or a central node is connected to one or more second-level nodes. Each of these second-level nodes is connected to one or more third-level nodes, and so on. Each node in the network has the same number of lower-level nodes connected to it. This number is known as the branching factor. The following figure displays a tree topology. A tree topology. The Internet is the best example of a tree topology, where multiple hosts and clients are connected to form a tree network. Consider another example. UVW Computers is a large computer manufacturing company, which has several support centers in different parts of the world. The support centers have hundreds of computers and other devices, such as printers, scanners, and servers, which are connected to form a big network. The computers and the Internet is the best example of a tree topology. Hybrid topology. A hybrid topology has the characteristics of more than one standard topology, such as the star and bus topologies. In a hybrid topology, each section of the network follows the rules of its own topology. Usually, hybrid topologies are composed of several topologies, which makes it difficult to maintain them. Typically, large networks consist of several smaller subnetworks, and each subnetwork may include different topologies. The two most common types of hybrid topologies are the star bus and star ring topologies. In a star bus topology, several star networks are connected to a single bus. On the other hand, in a star ring topology, several ring networks are connected to a central device. The following figure displays a star ring topology. A star ring. Understanding the logical topology. A logical topology describes the paths for flow of data and the network locations where the data paths converge and diverge. By understanding the logical flow of data in a network layout, you will be able to troubleshoot specific network problems where the physical topology may seem fine. For example, as a network administrator, you need to be aware of the logical topology of a network to be able to understand how a printer communicates with the other devices on the network. The following list presents some of the common logical topologies. Bus topology, ring topology, star topology, bus topology. In a logical bus topology, only one node can send data at a time and all other nodes receive the data at the same time. For example, in a software development company, the central server releases new software updates. To distribute this new software update, it uses the logical bus topology. The given figure shows a logical bus with a physical star topology. In a logical bus topology with a physical star topology, the bandwidth is shared among nodes or hosts. The first time you see it, the physical topology may seem like a star topology. However, the data flow pattern shows that the switch allows a single and continuous stream of data to flow from the sending node to all other nodes connected to it. Ring topology. In a logical ring topology, each node receives data from its upstream neighbor and each node transmits data to its downstream neighbor. The physical layout of a logical ring topology corresponds to that of a star topology. However, the data in a logical ring topology moves through the network in a circle. A ring topology is usually used in engineering and manufacturing industries, where all the computers that control processes in a network work in a sequential manner until the task is completed. For star topology. In a logical star topology, all nodes are connected to a central device. The central device checks all the nodes in the network to determine whether it needs to send data. The central device also controls the time for which the transmitting node has access to the transmission line. This central device that manages signals and enables the transmission line is known as a multiplexer. A star topology is one of the most common network topologies and is used in home or small office networks. For example, Publishing and More Incorporated is a desktop publishing company. When an employee using a computer in the network needs to print a document, it gains control on the network and all other computers wait until the printing is done. The following figure displays a logical star topology controlled by a multiplexer. A logical star topology with a multiplexer